All right, welcome back. In this screencast, we're going to take a look at Gauss-Jordan elimination, which, if you were paying attention in our last lesson, you really already know how to do, because we did Gauss-Jordan elimination with a 2x2 system. So let's take a look at a 3x3 system and work through the process. So this system will say x plus y plus z is 9, and x minus y minus z is -1, and x minus y plus z is 21. Now, we already know that we're going to take this system and turn it into an augmented matrix where this is where all the equal signs are. And the goal will be the same. We're going to want ones on the main diagonal, zeros everywhere else. Ones on the main diagonal, zeros below it, zeros above it. We already have this one, so we're going to use that one to get zeros below it. And the way we're going to do that, we're going to make this a 0 by taking the opposite of row 1 and adding it to row 2. And we're going to take the opposite of row 1 and add it to row 3, replacing row 2 and row 3 with what we get. So row 1 stays the same. Row 2, -1 plus 1, -1 plus -1, -1 plus -1, -9 plus -1. -1 plus 1, -1 plus -1, -1 plus 1, -9 plus 21. Now we already know what y is, right? We already know what y is. So now our goal is to make this a 1 somehow. And the way to do that, well, we'll take -1/2 of row 2 and stick it in row 2. Row 1 stays the same. Row 3 stays the same. Row 2, oh golly, that's happening in real time. Now, you may aptly wonder how we're going to get a 1 there, and that answer is going to come from, well, we're going to have to swap those rows at some point. Let's swap them now. Let's swap them now. Let's swap row 2 and row 3. That's fair. And then we'll do the thing we know to do, take -1/2 of row 2 and stick it in row 2 so that this becomes row 1 remains the same, row 3 remains the same, and row 2 becomes the thing we think it will. Then once we have this 1 rather, we get zeros below it by saying, let's take that second row and double it and add it to the third row. Now, why was it important that we get these zeros first? Because those won't affect anything going on here. Row 1 remains the same. Row 2 remains the same. And row 3, twice this plus that, twice this plus that, twice this plus that, twice this plus that. Not too shabby. Well, now we already know what z is, and we can confirm that. Row 1 remains the same. Row 2 remains the same. Row 3 is this. Now we know what z is. Now we know what y is. Time to get zeros here. We've got the 0 here. It's time to get zeros here. How will we do that? Well, we'll take the opposite of row 2 and add it to row 1. We'll have to do this in 2 steps, won't we? Let's take the opposite of row 3 and add it to row 1. That's fair. So that -0 plus 1, -0 plus 1, -1 plus 1, -11 plus 9. And then the last step would be to take the opposite of row 2 and add it to row 1. Stick the answer in row 1 so that row 2 and row 3 are untouched. Opposite of this plus that, opposite of this plus that, opposite of this plus that. Opposite of this is 6 plus that is 4. And now the solution is staring us right in the face. 4, -6, 11. A little bit of vocabulary. This matrix is what we refer to as being in reduced row echelon form. The ones go staircasing down. There's no one to the left of another one in the lead of a row. So the ones lead the rows. There are zeros everywhere else that it's possible. And the ones cascade from left to right, if that helps. Okay? Okay. So take a moment, like hit the pause button when this comes up on the screen. Oh, let's do it where this is the second equation. Let's take a look at x minus 2y plus 5z is 3, 2x plus 3, because then it gives you the 1 up here to start with. Minus 4z is -1, and 5x plus 4y minus 3z is 1. Take a moment, hit the pause button, play through what it looks like to take this augmented matrix and try to get ones on the main diagonal, zeros below it, zeros above it. It's a very similar process to this one. Hit the pause button, and in about 10 seconds, my work will appear. Okay, so I'll scroll down and you'll be able to see that we don't end up with something in the nice ones everywhere, zeros everywhere else. Like we don't get that. So how do we interpret this? Well, we've got a row that's all zeros, and that means that our system doesn't have a nice solution. Instead, z can be a parameter. So we let z be some parameter t. And we recognize that this second equation says that y minus 2z is -1, which means that y is, kick this over to the other side, 2t minus 1. And this first equation says that x plus z is 1, which means that x is, kick that over to the other side, -t plus 1. And whatever you want t to be, there's a y and an x that generate it, that are generated by that. And so we have a parametric solution to the original equation because there are infinitely many solutions as indicated here. When we gather, more to do and ways to apply it. See you there.